All right, we've got an equation to solve here. It's got a couple of parentheses, but it doesn't look too bad. So we get rid of the parentheses. We distribute the 5 through the first set of parentheses. 5 times x is 5x, and 5 times 4 is 20. Then bring down that plus 3. On the right side, we've got 10x, and then we have to distribute the negative 5 through the second set of parentheses. Now watch the signs. Negative 5 times x is negative 5x. Negative 5 times negative 6 is plus 30. Now we collect the like terms on each side. Well, 20 plus 3 adds up to give us 5x plus 23. And on the right side, 10x minus 5x is 5x plus 30. Now you might look at this and already see something that looks a little funny. But if you don't, no worries. Just we know the process that we have to follow. We want to get x on one side and the number on the other side, all the numbers on the other side. So let's continue with that approach. So I've got this 5x plus 30. I don't want this 5x over here. I want to move it over to this side. So I do that by subtracting 5x from both sides. All right, let's do that, and when we see what happens, the 5x minus 5x cancels, so we're left with 30. But on the left side, it also cancels. The x's also cancel. So the 5x minus 5x is gone. The 23 is left. Now this is what's weird. The variable went away. There is no variable left in this equation. When that happens, when the variable disappears, and what is left, what remains, is false, then we say that there is no solution. So the option you might see in my math lab will say that the solution set is empty, meaning there's no solution. This type of equation in which there's no solution is said to be an inconsistent equation. Now if, and it didn't happen, but if the variable dropped away and we were left with, for example, 23 is equal to 23, or any true statement, it could be 4 equals 4, or 0 equals 0. If the variable drops away and what's left, what remains, is true, then this is called an identity. And what that means is that there are an infinite number of solutions. An infinite number of solutions. Let's see if we can maybe write that so you might be able to read it. Infinite number of solutions. In other words, any number you plug into the original equation would work. Okay? But again, in this particular case, we had no solution.